Hi guys, welcome back. We're going to cover section B and C of chapter 3 today. So we're going to continue talking about maps. So last section we talked about the fact that it's really difficult to take a three-dimensional map and turn it into two-dimensional. And so in order to fix that, we use these things called map projections. And you get all these funky shapes and really it's just taking like smaller sections of the map and kind of spreading it out. The shape of the projection and the focus of the projection depends on the purpose of the map. Okay, so if you're wanting to look at something close to the equator, that's going to be one type of projection. If you're looking at something towards the North Pole or South Pole, it's going to be a different type of projection. Okay, so this is just something that has been done in order to reduce those distortions. Okay. Standard maps, you can have any different kind of map. This is a really colorful map. It's actually showing the soil moisture regions, soil moisture of the contiguous United States. And you've got this little legend down here. Let me get my pen. You've got this legend down here that kind of explains what all those different colors mean, okay? That's one kind of map. We'll talk about that in a second. First, topographic maps, okay? A topographic map deals with something known as topography, which is the shape of the land, specifically the elevation, how flat or how steep and mountainous the land is. We're going to talk a little bit more about topographic maps on the next slide, okay? We can also get political maps. That's your typical map. That shows like the names of states and countries and cities and capitals and things like that. It shows borders, whatnot, okay? A geographic map would be like what you see on your phone or like the navigation system in your cars. That shows things like roads and other natural features, in addition to the man-made features like waterways, rivers, and oceans and things like that. Okay. This map on the side here is actually a thematic map because it's collected data and it's put it into a map form. So by looking at this map, we can very easily see, okay, blue is aquatic. We can see that all those blue areas are very wet areas. If you don't know, what flows right through there is the Mississippi River, so that makes sense, okay? Down on these colors, it's very arid, okay? That's more of the desert region, and again, we live right about there, and usually we're in a drought, so that should make sense, okay? So let's go back to these topographic maps, okay? Topographic map attempts to take a three-dimensional land feature and turn it into two-dimensional again, okay? But not just a picture of it. A topographic map has all these funky lines to it, and there's numbers attached to it. Those lines are known as contour lines, and what they're doing is they're connecting areas of the same elevation. So you can kind of see this 550, there's 600, there's 650, and then if you follow those lines, it's showing you what the elevation is. And kind of if you imagine, let me change colors here. If you imagine a mountain, okay, here's a mountain. Okay, well, if I had a trail going around the mountain that way, that trail is going to be at the same elevation. It's a higher elevation here, it's a lower elevation here. So that contour line is going to kind of follow that elevation. And then there's going to be another contour line down there, and then another one down there. And so these topographic maps are kind of a top-down view of all those rings showing the different elevations, okay? If the lines are very close together, that means it's a steeper incline. It means the elevation is changing faster. If they're spread apart, that's a more of a gentle slope. It's not changing quite as quickly, okay? And then a topographic map would also include something known as the contour interval. And that contour interval tells you what the change is between each of these contour lines. So I've got 600 here and I've got 650 there. So I can just count and know that must be 610, 620, 630, 640, 650. And so what that tells me is that the contour interval of that map is 10 feet, okay? That would also be listed on the map somewhere because sometimes the lines are farther apart than that. So that interval is that change in elevation between lines, okay? Finally, we get these really fancy maps called GIS maps, and that stands for Geographic Information System. And if you look on page, let's see, we're into section C now. If you look on page 66 in your books, it talks a lot about that. A lot of the computer-generated maps are very complex, and they're layered, and they show a lot of different information. Okay. These maps used to be put together by a process known as surveying, and you might still see some surveyors on the roads, and they have this little like tripod device with this little instrument on top of it, and it's kind of poking out like that. And what that is it's a measurement tool, and so they start at a fixed location, and then through that surveying tool, they focus in on something else, and that instrument will tell them how far it is. And so it used to be that surveyors would do that to even shape the land and figure out the distance between different landmarks. This is all kind of done computer generated now, and by something known as remote sensing, which is aircraft flying over and taking pictures, or even satellites out in space, out in orbit, taking pictures and gathering the data of the land features that way. There's also acoustic sensing, which is how we map the ocean floors. So light doesn't travel through water very well. And so you can't really just take pictures through the ocean to get the ocean floor. And so what scientists do is they actually emit sound waves through the water. This is known as sonar and has been used for a long time. And then the computers read those sound waves coming back, and they're able to kind of calculate the time it takes for the bounce back of the sound, and they create a picture from it. And so that's how we map the ocean floors, okay? I want to kind of get out of this for a minute and take you to Google Maps, okay? Again, I love maps. But these Google Maps are kind of those GIS maps. They've got different layers to them. You can see all kinds of different things. So this is just the map of where I'm at right now. I'm sitting at school right now. But I can add different layers to this, okay? I can add traffic. This is actually the current traffic right now. I can add bike trails, okay? And so I'm looking at different data on this map, okay? I can search for things. I can also, let's see, I can change to the satellite view, hopefully. Looks like it's gonna go really slowly. There we go. And then I can also do the street view. So let me move myself out of the way here. I'm gonna drag this little guy down right there. Boom. There we go. Now I've got the street view of, guess what? You should recognize this place. That's our school, okay? And so photos have been taken. Sometimes you see people driving by, and then it's been put together into these really, really high-tech maps. You can actually go down the street more and you know, do like a 360 view. Okay, there's the restaurant across the street, all this stuff. You can do this all over the world. Okay, you can go on trips that you never thought possible. So let me go back to my regular map view. I'm done with the street view. Whoa, map. All right, and I want to show you what happens with these little distortions. Okay, so I don't need the bicycle anymore, but let me zoom way out. I think I'm on globe view right now. Sorry, it's lagging a little bit. Okay, there's the globe view. Okay, you can still see Brea right in the middle there. Let it load up a little bit. All right. So this is a pretty accurate view because this is attempting to show you where things are on the sphere of the Earth. Okay. Now I want to show you. Here's Antarctica down on the bottom. It hasn't loaded yet. There we go. Okay, you can see Antarctica down there. Watch what happens when I change from this globe view back to just the flat map view. Okay, so everything spreads out. You can see that South America and Australia all of a sudden got farther apart. But now look how ginormous Antarctica is. Okay, so that's some of those distortions that I was talking about. Okay, watch when I do this again with North America. Let me go back to the globe view. You can see things just kind of get shifted away. Alaska is actually much farther away from us down here than it looks like on a flat map. Okay, there it is, comes closer to us. So those distortions cause problems sometimes. Anyway, I believe that is all for section B and C of chapter 3. And I will see you guys later. Go play with some maps, okay?